Okay, chapter 2, solving one-step equations. We're finally starting on some algebra here. And we're going to start with some definitions here. I'll be using the term inverse operation. An inverse operation is an operation that undoes another operation. For example, subtraction undoes addition, or addition of the negative, and division undoes multiplication. We've also seen it on your calculators where you hit the second function and then the x squared key. That's because square root undoes x squared. So those are all examples of inverse operations. An operation that undoes another operation. All right, addition, subtraction, and multiplication, division, property of equality. Here's what we're talking about. This is the whole balance beam thing. Whatever you do to one side of the equation, you have to do to the other. So when we're looking at, let's move this over here. So here's our balance beam right here. Center it right there. We have x plus 4 equals 2. If we want to get x all by itself, which is our goal in solving this equation, we need to find an inverse operation for adding 4. You can see right here we have x plus 4 equals 2. So what we're going to do is add a negative number, add negative 4. And if we're going to add negative 4 to this side of our balance here, here's my balance, there's my fulcrum. Picture a teeter-totter right here. And what I'm doing is I'm subtracting 4 from this side. So I have x plus 4. I've put this minus 4 or added a negative 4 here, so I need to do the same thing to the other side to keep the balance. So adding a negative 4, subtracting a 4, same thing. So that's why we subtract 4 or add a negative 4 to each side. Right here you'll see that 4 plus negative 4 equals 0. A lot of times we say these cancel out. It's a canceling to equal 0. And so I have x plus 0 equals 2 plus negative 4, which is negative 2. And so therefore I get x equals, let's move this down just a bit, x equals 2, negative 2. We'll box our answer. And you can see that if I plug negative 2 in right here to the original equation, negative 2 plus 4 is in fact equal to 2. Alright, so here we are. Another fulcrum over here. Put the fulcrum in the middle. The balancing point, the fulcrum, is the equal sign here. On this one we have x divided by 3 equals 2. The inverse operation of dividing by 3 would be to multiply each side by 3. And so I have x over 3 times 3 equals 2 times 3. Here the 3's cancel out, and that's a canceling to equal 1. And so we end up with x equals 6. Move on to example or problem 1 here. We're going to look at one problem of each type. On problem 1, I have x plus 3 equals 27, so what I'm going to do is subtract 3 from each side, or add a negative 3. So I have x plus 3 minus 3 equals 27 minus 3. The inverse operation of the addition here is subtraction of 3. And whatever I do to one side, I'm doing to the other. And so here I have just x left over, and 27 minus 3 is 24. And a quick mental check says 24 plus 3 equals 27. I'll box my answer. Okay, so let's take one that has a subtraction sign in it. It says x minus 4 equals 12. The inverse operation of subtracting 4 would be to add 4. I should say at this time, it is okay to write it out vertically. That would be okay. Here we have x plus 0, or x minus 0 equals 16. I'll show you what I mean by that. Some students like to work vertically here. One thing you need to be careful of is if you put the plus 4 underneath the negative 4, you need to, when you go to the other side, only put the plus 4 underneath its like term. So I know there's only one term on the right, but you want to make sure that the plus 4 is only underneath the 12. If there happen to be other terms on the right side, you would only put the plus 4 underneath that constant term 12. So you may use this vertical type of setup. You just need to be careful about it. It can lead to some misunderstandings when we get to more complicated problems. All right, problem number 3. It says negative 2m equals 36. So we have, if I were to read this, it says negative 2 times m equals 36. The inverse operation of multiplying negative 2 by m would be to divide by negative 2 on each side. So 36 divided by negative 2. Here we have negative 2 divided by negative 2. That gives us 1, top and bottom. And 1 over 1 times m is just m. And 36 divided by negative 2 is negative 18. So what I'm saying here is if I plugged in negative 18 up here for m, negative 2 times negative 18 should equal positive 36. All right, problem 4, solving an equation using multiplication. Here we have x over 4, and we're going to multiply it because x over 4 is the same as x divided by 4. The inverse operation of division is multiplication. In this case, we're going to multiply each side by 4. So when I multiply each side by 4, I can cross cancel. 4 goes into 4 once. So we have canceling to equal 1 in this case. That leaves us with x equals negative 9 times 4 is negative 36. Let's check that, quick mental check. Negative 36 divided by 4 is negative 9. So I've solved it correctly. So those are one variable linear equations for solving for the variable